Hi, good afternoon, good morning, everybody. It's great to see you again to our third webinar in the Urban Greenhouse Challenge. My name is Marta Ehers, and I'm here in the studio with three amazing speakers. Professor Leo Marcelis from Wageningen University, Dr. Hilke Bos-Brouwers also from Wageningen University, and Dr. Daniel Podmirseg from Vertical Farm Institute. We have today for you a special program, extra long, with 3 presentations. 2 of them will focus on indoor farming, so we'll dive deep on indoor farming and principles and other elements. And then we'll take a step back to discuss actually the design and the guiding principles for circular design. So we'll have 3 presentations, and after every presentation, we'll have time for answers and questions. So please be active on chat, pose your questions once they appear in your head. Don't wait with that. And I think those are the most important things I would like to share with you right now. And I would like to give the floor to our first speaker, Professor Leo Marcelis.
Thank you, Marta, and nice to meet everybody here in this online event. And I guess that now my presentation will come on the screen. Yes, and that's the last slide. So then I need... I could also try to
why not?
Backward position. And when we are at the start, I will ask you how many slides you can remember already.
Yes, sorry about that. I don't know how to review the presentation. Yes, we are there.
Yes, sorry, then I have seen all the secrets of my presentation already. So thanks a lot. Nice to meet you all here in this online event. I will talk about indoor farming or vertical farming, just how we would like to call it, where I focus on is growing crops indoor, in buildings with artificial light. And now I can start to the next one. So if we're talking about vertical agriculture, what I'm talking about, or vertical farming, growing crops in buildings, usually it is on multi-layers above each other. And what is very important is that we have a full control of the whole production process. We have very high yields, which make that we only need very limited land area. And we can do it anywhere. We are not depending about fertile soil, but it can also be anywhere with respect to the climate. It can be in the very hot areas, hot and dry areas of the world, or in the very cold areas. And it can be very nearby areas where the people are living, in the urban areas. And then with all those systems, because of the full control, we can really guarantee and say, well, on a specific day, we can produce so many kilograms of a defined quality. Before I start, and at this moment, there's a lot happening in the vertical farming world. There are huge investments, and you just see here a few examples. I did not try to be complete, but just some rough numbers to give you a bit of an idea on what is going on in this world in the past few years. Amazing investments all over the world. Before I go do a bit more about it, it's maybe nice to look a little bit back in time. This is a picture from about 100 years ago about what greenhouse horticulture started in the Netherlands. Relatively very low technology level. This is about halfway the 20th century, so let's say 1950, 1960. We see already a little bit more technology, but compared to now, it's very limited. Here we see modern greenhouse, although I have to admit, these pictures are also 20 years old already, but still, this is what we could still see nowadays. Greenhouses with lighting. Here, HPS lamp. Nowadays, we're moving towards LED lighting. And if you see all these developments, then the next step is to grow completely indoor, where we see here an example of, and then it is maybe not so surprising, all those developments of more and more technology, more and more control over the production process. But this indoor farming can have different forms. It can grow from very small scale to an appliances in the homes of the consumers, very small. It can be a little bit larger. Here, what we see an example in supermarket, where you can see where the plants are grown in the supermarket, or what we see growing crops in containers that can be placed also just anywhere or can be transported. Or we can have very large scale, more warehouse type of production facilities. If you look at vertical farming, there are many positive things, but it's also always good if there are new developments. What are bottlenecks? And two major bottlenecks is at present is the energy use and other costs. So what type of actions are needed? Well, I think it is very important that we reduce the energy use. And I think also the energy use is high, but also I think there are a lot of opportunities to further improve it. And energy use, it starts with the lighting. There's a lot of, because all the light comes from LEDs. LEDs are very efficient, but we still need a lot of light. So therefore we need a lot of electricity. Well, there will be further improvements in the LEDs, but more important on that we make more efficient use of the light. A lot of opportunities there still. And if we reduce the energy use or the amount of light needed, we can also reduce a lot of the cost. So that works on two aspects, very good for sustainability and for the cost price. First, looking at the plant, what are the plant needs, but it is also about how to optimize the climate, how to optimize the conditions below in the root medium. What type of technology are we using? And then finally, we should also look on how can we integrate it in an urban energy system. I will not say much about that because that will come later this afternoon, also in a talk. Even then, if we reduce the energy use, so we have further improved the sustainability, we have reduced the cost price, I think then the most important is that we have a better product with a higher added value. And that can, if it is more expensive, then that can also balance the higher cost price. As I said, in these systems, we can control the crop to a very high extent. And one of the tools that we have to control the crop is by manipulating the light environment. And light, and it is about the intensity, which directly affects the photosynthesis. It is about the day length, how many hours of light during a day. It is also about the spectrum. So the spectrum is the quality of the light. But you can also think of what is the direction of light? Solar light always comes from the top. But with LED lights, it's not necessarily all on top. We can also think of having it in between the crop. And what does that do with the physiology and finally with the yield and the quality? And we have to think that light also represents heat. Well, all these different factors of light we can use to control the crop. And I would love to spend a few hours of explaining all those effects, but my total presentation is only 15 minutes, so I can't do that today. Just show you one example of how big the effects of light could be. This is just a very simple example of that we have 3 different light levels in the lattice, and you will see on the left-hand side the high intensity, the right-hand side the low intensity. You see the effects on how big the plants are, how the plants look like. And then if we go to the next slide, that's exactly the same experiment, but now the plants are harvested, stored in the darkness for 13 days or for 20 days, 21 days, that's on the lower row. And what you can see here is depending on the growth conditions, so whether they were grown at a high intensity or whether they were grown at a low intensity, that we have a better shelf life if the light intensity was high. So at the left-hand side, we see the lettuce after 13 days looks very fresh. After 21 days, I would say it does not look very fresh anymore, but still with the 500 micromoles, so that those grown at high intensity on the left-hand side, they definitely look much better than those who are grown at a low light intensity. So we can change the quality after harvest by what the conditions are during the growth. And this is just one of the examples of how we can affect it. And then the interesting thing, the effects what we see here on the shelf life, which is as such important, was due mainly because there were more sugars and more vitamin C in the plants grown at a high light intensity. This vitamin C is good for the plant, it creates a longer shelf life, but of course it's also very interesting for us as a consumer. There's a lot about what we can do with the light, but in the end, light is there are more factors than light. It's also about the roots. How do we grow them? Do we grow them in soil? Well, typically we grow them on a substrate, or maybe without a substrate, just in water or in aeroponics. So we supply water, and with the water, the minerals. In that way, we give the plant exactly what it needs. We maybe supply too much, but everything what we supply too much is collected and reused, such that there is not any emission of the minerals, not any loss of the water. What we also can do is we can think of what we call biofortification. What is biofortification? Well, it's that we create a product with some extra minerals, for instance, selenium or iodide. And this can be important for some consumers. So it's a very interesting topic. And at the same time, we may want some nutrients we might not want so much, for instance, nitrate in leafy vegetables like lettuce. And then where we see in the research where originally we looked at, well, all constant conditions can be grown at higher light, at lower light, at a different mineral supply. And what we're now more going towards dynamic conditions, that we adapt all the environmental conditions depending on the developmental stage in a young plant versus an older plant. And what we can do now is we want to maximize growth. Initially, we can do all those factors which maximizes growth. And we find that if the last 5, 6, or 7 days, we focus on quality, that we can have a superior quality, but overall a very high growth rate. And I often get the question, how sustainable is a vertical farm? Well, sustainability has many different aspects. If we apply most ultimate level of hygiene and disinfection, I would say non-chemical disinfection, and that means if we ensure that no pests come in, we also don't need to apply any pesticides. We use very little nutrients, only the nutrients taken up by the plants, and all the remaining nutrients are continuously recycled, continuously reused. We have a very limited water use. If we grow vegetables like tomato in the open field in the Mediterranean, well, you need to do it very good, and then maybe you can go as low as 60 liters of water per kilogram of tomato. In a modern greenhouse in the Netherlands, growers use about 17 liters per kilogram of tomato. In a vertical farm, if we do it in a very good way and we do a regain also of the transpired water by the plant, we can go down as low down as a few liters of water per kilogram of product. And that is very important in many areas in the world. We have extremely limited land use. On one shelf, depending on the conditions, we can grow 50 to 100 kilograms of vegetables per square meter of shelf. Well, think what will happen if we have 10 layers above each other. That will make already 500 to 1,000 kilograms of vegetables just per square meter land area. And that is really huge. Less transport. If we have the vertical farm nearby the urban areas, or let's say in the urban areas, there's much less transport. Due to the short transport distance, due to a better quality and therefore a better shelf life, we have much less food waste. So many aspects of sustainability very good, but the energy use, that's a bottleneck. That still needs to be reduced a lot. There are more advantages of vertical farms. It's about having these guarantees, what I mentioned already. It's about food safety. If there is no contamination, no residues of pesticides, and no bacteria, or not unwanted bacteria on it. If we increase the nutritional value by, for instance, more vitamin C. We get a more healthy product. And then in the end, yeah, it also depends on the marketing concept, on local production, on that it is hygienic, and etc. What crops are we typically grown? What we usually see is leafy vegetables and leafy vegetables and leafy vegetables. So that is by far the most important crop at present. We see also a lot of herbs, but now we see interest shifting towards also crops like strawberries or tomatoes. It is not so much about the crops produced for the carbohydrates, not the bulk type of crops. Technically, I can grow any crop, no problem. But is it economically feasible? I think at this moment, those bulk type of products like corn or rice is not economically feasible, unless it is some specific niche market. It can also be high value crops like medicinal crops. What are some new developments? Well, there has been no breeding yet for vertical farms. Breeders are working on it. So there will be new cultivars coming up specifically designed for vertical farms. And then we will see we go towards the next step of better yield, better quality. And under those well-controlled conditions, we can get a lot of data. We can continuously monitor the crop. And using all those data together, combined with simulation modeling, combined with artificial intelligence, we can further and further optimize and control the system as a whole. And then we are going towards an autonomous control. We have, for instance, here where I am or wherever someone has a computer may control at one place the farms at different locations in the world. And then some conclusions. So where I briefly showed vertical farms, that we have a full control over the production process, that we can have those guarantees on what it is, that it is fresh, or in particular suitable for fresh produce. We can grow them anywhere. It's also still very new, so a lot of further improvements are expected in the coming year. Sustainability has many aspects. Most criteria, it shows very good, but energy use, that is still high. That needs to be reduced. Also, the cost price needs to be reduced, and there are ample opportunities for that. And with that said, I would like to thank you for your attention, and I would be happy to answer questions.
Thank you very much, Leo. It was a super interesting presentation. I really liked it. I remember that you gave also a presentation during the first edition of the Urban Greenhouse Challenge. And I was really curious, actually, what has changed, because it was almost 5 years ago, and we are now also looking a little bit back when it comes to Urban Greenhouse Challenge, and wondering like how this entire indoor farming scene or sector has changed in the last 5 years.
Yeah, so what's changed is what we see is where all the investments in the industry, which have been so huge in the recent years. So the sector, I would say still it is a small sector because it is so new, but it has expanded quite a bit. I would say in particular in the USA and in the Far East, but we also see it all over Europe, also in the Netherlands where it is coming up. So that's a bit from the industry point of view. I think some new things are also, well, everything is constant in those vertical farms. That's where we started. And now we also find out, hey, but a young plant has different needs from an older plant. How can we adapt that throughout the life cycle of a plant or throughout the day? Some things which I think are more new in development, that's developing new type of varieties, but I would say they are not yet on the market. And the other aspect is all the use of sensors. There we see a lot of development, but I also need to be honest that if you look at the companies at present, they use some sensors, but that they really use it to real control, well, that's still a big step to go, but that's absolutely developing at this moment. And how can we use a lot of initiatives you see on how can we use all the data from one farm, but combine it also with data from other farms. I would say that there are a lot of developments ongoing on those aspects.
And you mentioned at the beginning of your presentation that the cost and the energy are like the biggest factors in vertical farming. Do you think in the last past years the prices went down, or is it still as expensive as it was?
No, what you see, it is, well, anyhow, it is very difficult to give numbers of what the costs are. But absolutely those costs are going down. And that's what you typically see with new technologies. They are initially very expensive and then prices will go down. One component, for instance, of LED lighting, which is, if you look on how efficient an LED is now compared to 5 years ago, then the efficiency compared to 5 of the most modern LEDs, I think they are probably about 40% more efficient than 5 years ago. So that's huge reduction in energy use. So that makes already that we have a lot of saving on the energy use. And the LEDs, well, it's hard to know the exact prices, but I guess that the price, similar like chips, they usually develop and the price per chip always remains the same. But the chips in the computers, but what one chip can do increases so much more. And I think that's also a little bit comparable with LEDs. I think the price per LED probably did not change that much, but the output of light. So there we have already a tremendous reduction. So overall, there is a tremendous, also in other aspects, reducing the price, but still, I would say it is not yet a cheap system at present.
No. We have one question from Ricardo, who is actually linking to this discussion. So he's asking, how can we push the optimization of energy consumption? Do you have any thoughts about that?
Yeah, there are many things that I think it starts with using because most of the energy is used for the light, and if you have inefficient light, we also get a lot of heat, and then we need cooling. So it starts with using an LED, which is very efficient in terms of converting the electricity into the light. And the next step is that the light that we give, that it is absorbed by leaves. What I still see in a vertical farm is that young plants, they are maybe spaced apart. There is a plant here and there's a plant here. Well, then the light in between falls on the floor. That's lost light. What I also see still quite often, there are a lot of walls or paths where a lot of light falls on the paths or the walls. So first, and that's relatively, these are the easy optimizations. Be sure that light is absorbed by leaves. If it is not absorbed by a leaf, it is lost. It's lost energy. Once it is absorbed, well, then we need to be sure that we give the right spectrum, that we give the right intensity. And that, that's hard to give general guidelines for that. And also very much depends on the species, on the type of crop we are growing. But also that then the other conditions are okay. What are some, for instance, that there is CO2 supply. Regular outside air contains 400 ppm CO2. If you have a vertical farm, we do not supply CO2, well, the plants will take up CO2 and then CO2 concentration drops and then the plant stops photosynthesizing. So we need some supply of CO2. That's good, plants take that up. But if that is not properly done, we will not make efficient use of the light. And this is just one example of that. Also the CO2, the temperature, the air humidity needs to be adapted to the light level. So there you get this whole complex of things connecting. I always say first start with reducing the energy use, that we get most products with a good quality with less light and less total energy. And then once we have reduced the energy, then we need to think of where does the energy come from. Ideally, it comes from renewable energy. And we can think about those lamps produce heat. Can we use that heat somewhere else in surrounding buildings? And I think in one of the next presentation there will be attention to that. So I guess I should not. There's someone who knows much more about it than me.
Great. When I hear your answer, I think, wow, it sounds like it's very, how to say, complex. What you also said, and very, internet or like technology savvy to actually work with those systems. And we have a question from one of the people watching, Nicolas. He's asking, what are the options for low cost and low tech vertical farms? Does it actually exist? Even when I hear your story, I start to wonder.
Yeah, so where I start with relatively high tech, well, I think all these systems are relatively high tech, but of course there are different levels of technology. But I find this a difficult question because to look really for a low, this is not a low tech application, I would say, but of course still we can look on what can we do cheaper. Well, that it is about the LED lighting, but I think if we do there a low technology of lamp, I'm afraid that then they use a lot of electricity. So I would not look that in the light, but it is about, well, the system that we grow the crops in. So the type of building that we are using, or are we growing in water or on an artificial substrate, or do we grow in pots of soil? Probably maybe pots of soil are relatively cheap. So sorry, yeah, it is a bit difficult to answer on where are the cheap opportunities or the low tech opportunities, because in general it is a relatively high tech environment, this type of production system.
Okay. Yeah. Well, I would like to wrap up with one last question from Hertian. So he's wondering, like, if we have more sugar and vitamin C in the plants, does it mean that it will be more sustainable? So
I would say that is not directly about sustainable. So where I said with the lettuce that you have more sugars and vitamin C, they are good for the shelf life of the product. Well, a higher shelf life may contribute to sustainability if then it means that there is less, that people throw less vegetables in the garbage bin. But I would say these extra vitamins, well, it's good for a longer shelf life, for nutritional value, but not directly with sustainability. The sustainability comes from other aspects.
There's like maybe, sorry, I saw one question that is actually maybe nice to wrap up the discussion about, and actually it links to what you were talking about, autonomous farms. So there is a question from Nicolas who is asking how much human effort and organization is required to run a vertical farm. I think maybe that would be a nice way to wrap up this discussion.
I think if you look at present at the vertical farms, there is still a lot of people involvement in organization, and sometimes on those, in particular when they are small, a lot of labor, handwork, manual work for harvesting and those type of things. On the other hand, I think the larger scale vertical farms, they are ideally for mechanization and automation, this autonomous control, and then the number of people working there will be much less compared to the traditional farming.
Maybe in the future it will be totally run by robots.
Yeah, let's say that is what we expect in the far future. I think there will always remain some people, well, much less than now, but there will need some experts also seeing from time to time. But it could also be, because seeing nowadays can also be with cameras and with additional type of sensors from a distance.
Yeah. It reminds me of a webinar that we had last year about future of dairy farming, and actually there was this vision of a dairy farmer who is sitting in his office in front of computers. So very different type of farmer than we have now, and probably that's also what is changing with vertical farming.
Yes. That is what I foresee, that we get a lot of things, people in a control room controlling these, what I said, farms all over the world. But yeah, still there will also be some people on location before we are not needing those people anymore. Well, that will be quite some years.
Okay, great. So let's finish on that note. There are two more questions in the chat that we didn't discuss, one from Anna and one from Marijn. So if you could answer them in the chat, that would be great.
Yes.
And for the moment, I would like to give floor to our next speaker, to Daniel Podmirseg. Daniel, I think you're there.
I'm still here.
Yes. Great. I will turn on your presentation. I hope we start from the beginning. Yes.
Yeah. Perfect.
Okay. Well, enjoy the second presentation.
So, Marta, thank you very much. I'm very grateful for the invitation, and I hope to contribute some thoughts to all of you students here in the digital auditorium, and hopefully to have more fun in your vertical farm development. With your design, please try to be courageous and feel free to test new geometries. My name is Podmirseg. I'm architect by training, and I'm the founder of the Vertical Farm Institute, which now exists since 2016, where Tiffany Tsui, you know already, was in the executive board, and now we transformed the association into a company, and she's partner of it. Perhaps in the following minutes, I would like to give you, how could I say, an overview about the key drivers of the Vertical Farm Institute on a personal, and this is very important, but also on a professional level, and what's the core interest of our business. Most importantly, we are looking for energy efficient solutions to radically increase food production in the heart of the city next to the consumers. What you see here are basically these four different system borders, which are of key interest. That the bigger system is, the more positive externalities we can define on the reduction of land use, which is very important, yeah. CO2 reduction and minimizing, of course, dependency from hydrocarbon energy of conventional farming. This slide is a mix between that what we are doing and the personal one, a personal motivation. I was born in 1976. As you see on the back side, you see the CO2 emission curves. Yeah, and since 1995, we are meeting on an annual level, talking about climate change and reduction of CO2 emissions. When I started with my dissertation, the world primary energy production was on 500 exajoule. When I finished it, it was 550, and last year already 576. So as you see, the CO2 emissions are going up on one side, and on the other side, unfortunately, also the use of hydrocarbon energy. This is very important. And when we think, and if we say that the UN is right, and in 2075, we will be around 10 or more billion people. So what are the scenarios what we are talking about, or what is the strategy? On one side, we can say, yeah, we have to increase the yield per hectare, number one, but this also would lead an increase in the use of hydrocarbon energy, namely from 176 to 350. This is strategy number one. Strategy number two is land conversion. You are all conscious about it, the slash and burn practices. So we need an additional land surface in the size of Australia, and the best part of it, usable for agricultural production, of course, is under forests. And that would, in addition, release 900 gigatons of CO2 emissions. And this is a dramatic number because this is 20 times more than we emitted several years ago. And strategy number three, very simple. Let's radically reduce dairy and meat, but this is against every social trend, not in the Netherlands per se, not in Germany or Austria, but worldwide scene. Yeah, so socialist acceptance is not there, and try to imagine a politician who comes up with that proposal to be re-elected at the next elections. So this leads us to the current situation. 30% of the world primary energy production is directly related to the food sector, distributed on agricultural production, transport and distribution, processing, retail, preparation, and cooking. And with most of these parameters, of course, vertical farming or urban farming can compete with. Yeah, so let's just have a look on if strategy number 4 could be something we should investigate more time with. So the key advantages we've heard already from Leo, yeah, we have to produce 365 days, radically reduce the land use. So we are setting up a vertical farm on an already sealed level, independent from weather conditions, switching in our brain from square meters to cubic meters, closed cycles with water, herbicides, and fertilizers. And we also can radically reduce the energy costs in terms of independency of hydrocarbon energy. And we have to accept some issues the moment when it comes the integration of food production in the heart of the city. First, we have to think about what is the right building typology for it. So are we talking about a greenhouse? Are we talking about a vertical farm? Are we talking about a vertical plus farm? So namely a multifunctional building. Then we have to get to come up with specific answers on the production systems. So is it the box? Is it the plant factory? Is it in between intermediate floors? Is it food production on the facade, on the rooftop, etc., etc.? Then, of course, the decisions come up, talking about the building services or the HVAC system, the lighting system, very important. Is it fully artificially lit or is it just supplemental light? And then, last not least, coming up with the right decisions in the cultivation methods. So the first question, thinking about food production in the city, we have to think about what do we have for free. So what is the daylight distribution in an already existing building, number one, or in a design proposal, what you come up with. Yeah. The next thing, very importantly, this is also something what we have heard so far, having a closer look on the whole sigmoid growth curve, so the lifespan of the plant. So what do we need at what time? And how can we achieve it? Thinking about the level of comfort or setting up the right growing conditions for plants. This is one of the most important diagrams as a result of my dissertation, because what you see already, if we do it in a wrong way, then it's an energetic disaster. So what I developed is a skyscraper as a building typology, 3 with the same volume, 15,000 cubic meters with different levels. And the energy or the lighting demand is way worse than that what I compared with a high-tech greenhouse or a conventional greenhouse, and to some other numbers what I got from other vertical farms. On the other side, and this has to do with the AV ratio, namely the ratio between the volume and the surface of the building, it has a huge potential to radically reduce the energy consumption for heating. So, and as an additional information, I would like to share to think about what is the difference between a vertical farm or production entity with translucent or transparent building envelope compared to a plant factory or a black box. So what you see here is the power demand for tomato production on the lower side of all these 3 different building typologies, what I was talking to, and this is the energy demand if you substituting the whole energy with artificial lighting. Just for sensing, I'm sure you know that, or you know about that. This is a typical analysis of the daylight distribution in a building with intermediate floors. Of course, we have most of the light of the rooftop on one side. And when it comes into energy consumption in terms of heating, then I love that diagram because that can open our minds to rethink in our already how could I say, already built environment. So each and every level, each and every intermediate floor already has very specific climate conditions and the daylight distribution. Yeah. So it also could be possible when it comes into building refurbishments, thinking about that again, what we have and which plants or which products could be produced there at its best to radically reduce the energy consumption. As a next level, so now switching from the production entity to a vertical farm, which collapses the whole food supply chain within one building and translating that into a function and space program where each and every structural element of our global food supply chain can be imploded, then of course you are creating additional positive externalities. You are radically reducing energy costs for wholesales, refrigeration, transport, etc., etc. And for the first time, we developed that for a research project together with our partners at Graz University of Technology, BOKU and Siemens, where all these different entities have been considered in a building for Vienna. Another good example when it comes into energy reduction was an issue where the mayor of a city next to Vienna came up to us. There is a school building from the 70s, concrete building, super great heat loss, and only by combining this old building, so not tearing it down and rebuilding it, but extending it and combining it with food production, the energy consumption for heating already went down by 35% with no optimization. Interestingly, if we talk about food production in the heart of the city, then we have to understand and to accept that the vertical farm is a structural element of the urban system. So the moment when you start with your urban analysis, you get information about where interesting stakeholders are next by, where the potential clients are, etc., etc., in order to develop, let's say, the right delivery system. So when it comes into the discussion of the last food mile. It is complex, and that is the reason why we, from the very early stage on, already on a conceptual level, we are working on a parametric level with a graphic algorithm, where you already in the very beginning get your information from Energy Plus and from Radiance if you're moving into the right direction. So when it comes into the distribution of the building masses, you get a deeper understanding where you're placing what, because you get your information of the urban context, or the sun stands, etc. And of course, this tiny little box up here is the daylight distribution. Another interesting thought on an architectural level in the development of a multifunctional building, what I meant before, is this building for a city in Vienna, which was a design proposal where the vertical farm, the production, the market and the gastronomy got combined with additional functions like temporary living, co-working spaces, restaurants, etc., etc. So this osmotic wall could be understood as an interchange between O2, CO2, heat, cooling, etc., etc. And lastly, and this is something, a project which is very close to me because it's super actual, because there are already private investors moving in that direction, finding for solutions in the reduction of CO2 emissions. This is an investors building it's only 25 years old, in such a bad quality that each and every one who was working in there, now they are moving out. And our proposal was that we keep one part of it, change it into a hotel, and the rest of the surfaces and spaces of the building get activated for food production. This is a picture on the very rooftop, the combination between food production to get a sense in that what it actually means, producing food indoor. It also has this conflict between the level of comfort and the optimum growing conditions, of course, so it's not a high productive entity and therefore it never could be commercial. But the moment when you combine these things and you try to leverage it and bringing it together with restoration or leisure area, then it can create this additional value for a building. Lastly, to get an idea of the different levels which got activated for mushroom production, fish production, microgreens, and this paternoster system, which got invented already 50 or 60 years ago in Vienna, to really radically increase this food production per cubic meter. And this idea, of course, then can be translated and should be further developed on urban development areas. So we already have a lot of possibilities to grow food indoor from a super low level, from urban farming, which have a very high social value, to high-tech indoor green productions, which are commercially feasible. To conclude, these are three of the most important key parameters in our thinking and in our project development. With basically, it's the radical reduction of the building footprint and therefore the reduction of the additional land use, what we need in the future to radically increase the cultivation area per cubic meter and use what we have for free, especially the sunlight. So thank you very much, and I'm looking forward for your questions.
Thank you very much, Daniel. Very interesting presentation. I saw also a lot of numbers and complicated graphs. So, like, where would you advise students to start actually? Because I think it now looks very complicated to start with.
I mean, one of the most important things on a creative level is actually to think about or to come up with a definition or a vision. I radically want to maximize food production in the city. So the first of it is, okay, getting a better understanding or a feeling of the site. So where is it actually placed? Getting a sense, and this doesn't have to be simulated, but getting a sense is where's the sun going up, where's the sun going down. So really coming up with, and this is a design process, yeah, coming up with the right geometry to maximize the use of the energy, what we have for free. And the second thing is, of course, this is perhaps this is something what you are doing. You have an overview in different production methods or cultivation methods, in that what could be usable for in the food production.
And what is your like? What in your opinion works better? Like restoring an old building when it comes to cost efficiency, or starting from the very scratch and putting something new on the ground in the city?
No, I'm just thinking about the students now, and in order to really be creative and starting this process of creativity, I would say start from scratch, because the already existing building increases the complexity.
Okay, but in a real life, in your practice as an architect and as a consultant.
What do you mean? The way how what my wish is? So the big picture is to the development of new building typologies. Yeah, really start from scratch. So, but on the other side, I don't care if there is a refurbished building. I have a similar driver because I take these challenges seriously. Yeah. So the climate change, CO2 emissions, the energy issues, etc., etc., and the embodied energy. So the energy what is already in that building, which was set up 20 or 50 years ago. This is something what is always way higher than the whole operative energy of the future. So there is a huge chance in really thinking about how could you reuse that building.
Okay. We have a question from Mukesh, and he's asking, what are the different energy efficient ways of using natural sources?
I'm sorry,
your battery is down, I guess.
I'm wired, so it can't go down.
Okay, let's wait a second.
Okay, problem solved. Sorry.
Works?
Yeah.
Okay, great. So there was a question from Mukesh, who is asking, what are the different energy efficient ways of using natural source of energy to power the grow lights? So it could be, for instance, what kind of batteries are there?
This is a good question. I mean, I only know these conventional projects, which you perhaps also know. Yeah, the Tesla projects on a lower level, but the energy storage is really one of the key issues. Yeah.
And are there any interesting solutions already on the market?
I mean, this technology is rapidly developing, and the batteries are way better than already 3 or 5 years ago. But this still is something what has to be radically developed and intensified.
Okay, so
yeah.
So you cannot point the students to a specific technology that they could incorporate in their system.
Perhaps this is I don't know how the situation in the Netherlands is, yeah, but the energy supply of renewable energy, this is something, I mean, perhaps for the students, it's way more interesting to getting a better sense in that energy what we have for free as a first step, thinking about what can you produce, yeah. So getting a deeper understanding in geothermal energy, so the solar potential, solar thermal potential, and perhaps for wind turbines, yeah, because the building envelope itself is actually something what you could activate for.
Yeah, yeah. We have also an opinion question from Rodrigo. So he's asking, is it worth encouraging small producers to switch to an urban farming system, or is it better to support large companies to develop more architecturally efficient systems? What do you think?
This is a good question. I have to reread it. Wait. I have a tendency encouraging small producers to switch to an urban vertical system. Small, tiny, little production entities to densify the network of the city.
Okay. And what would be the reason? The densifying the...
There was one very good contribution from Saskia Sassen at our first Skyberries conference in Vienna by talking about vertical farming, and I will never forget that. Yeah, the moment when she started thinking about the resiliency of cities, she's always talking about a stable sub-economic urban network. So the stronger that is, the more resilient the city is. So the less dependent you are from bigger structural elements, the more resilient the city is.
Okay, nice. Thank you. We also have a question about photovoltaics. Is that an interesting option for vertical farms, photovoltaics being integrated in the building design?
Yes, it is. So you have your building envelope and you have to come up with the right decisions. So not being, now let's put it that way. That was a very interesting investigation with a student of mine at Graz University of Technology. She developed a museum lifted from the ground at 12 meters, yeah, and we activated all the surfaces of that box, of that museum, with photovoltaics. And the interesting thing was at the bottom of the building produced more energy than the north side. So the only thing what I want to say with that is that each and every surface activated for power production for free is a good decision.
And is there a building or a project that you would like to refer students to if they would like to study the optimal way of using the energy in the city and for food production?
I still have a favorite building from Nona. Perhaps I'm sure you know that you know her already. Vertical Harvest in Jackson, Wyoming. Yeah, because that building, which is already operating now for several years, is something where you can learn a lot from different production methods and how to increase this space efficiency, namely increase the cultivation area per cubic meter, number one. Number two, they have their transparent building envelope and it's working. And as a third thing, which has of course to do with sustainability, but on a social level, is this integration or creating a new public hotspot, which is successful very rare in the United States on a successful way. So have a look on that building.
Yeah, and if you missed the webinar that was last week, it was we had Nona here as a guest speaker, so that might help you to remember her project and study her design.
Yeah.
Okay. Thank you very much, Daniel. I think it's a really great contribution and really helps to think about energy in the city and integration with the buildings. I would like to give the floor now to Hilke. Are you there, Hilke? Yes. Thank you, Daniel.
Yes, for sure.
Great. I will start your presentation. Let's see if that one starts from the beginning. Yes. Okay. Enjoy.
Yes, thank you very much, Marta, also for being also a coach in the general outline of the Urban Greenhouse Challenge this year. I was also a coach in the previous edition. So I'm really looking forward to see all the great conceptualizations by the student teams this time. And after two very, maybe even a little bit more technically oriented, specifically greenhouse vertical farming contributions, I actually want to invite you to take a step back, because my expertise is much more in conceptualization, the framework behind decision making that contributes to circularity. Also trying to understand circularity, the different demands there are from different stakeholders, and how you integrate that into a selection of options that really fit your situation best. And specifically today, I will bring to the table experiences and some hopefully useful steps and considerations from the Circularity by Design flagship project, to which I'm a project lead, which actually combines quite a lot of different expertises in the team constellation. So I actually also hope that your own team consists of students, colleagues from very different expertises, because in my opinion, that really helps building a good design. So very specifically for circularity by design in the context of cities, which is of course larger than a building, but it has that connection to the city as well, is to really consider the following question: is it how to make that transition from an urban bioeconomy that is very linearly oriented to one that is much more circular by design. And that is actually a question about, if you look at the city level, it needs inputs in all times, all kinds of agri-food produce. It does something with it, and it also has a lot of waste. Now, circularity actually means that you try to avoid the wastes, loop it back into the city scope, and actually reduce the amount of waste that are going outside of the city. And that is actually also a very good starting point from your own design of your challenge. By design is not necessarily the architecture of a building or something else. It actually is defined here as it is intentionally this way. It refers to the intent and purpose from the people who are involved in that city, as well as the smaller parts of the city. And doing so, it really addresses needs, demands, requirements, functions of those people. And what are actually those demands? They are really related to having safe, affordable, and also sufficient food. It needs to be contributing to the well-being of the people living there. And also that zero waste, zero emissions, because it does need to have a direction of how you want to manage that, because you can provide in safety and affordability and all those other stuff, while you actually have a lot of waste, which is not the intention behind circularity by design. So so how to make that translation going on? Because you can imagine yourselves as being one of the people who need to organize that process of translation in presenting your design and lighting it from various angles. So what I want you to take yourself as challenge is to really wonder, what do the people who will be living in my building, working in my building, recreate in your building, what do they want? What do they aim for? How do they want to live and work and leisure for themselves, but also in the context of the whole city? Imagine yourself waking up in a city when, or in the building when it's really there. What does it look like? How is it organized? Imagine yourself walking around it and see it actually working. So you then can develop this approach that really allows you to create that decision-making process from the bottom up for the people who are using it. So you can really align the design on that smaller scale, but also connect it with the other parts of the city and even with other levels outside the city, country level, even globally, if you like to. So therefore, we have this 4-step process, actually, we are describing in that project, which builds on a very specific dedicated framework and design principles, a parameterization, a decision-making process, and translate that on challenge level, which you can kind of consider in your own context as your challenge, your building, your site in Washington, as well as how it connects to the urban level achievements. Okay, so what are we talking about then if we are talking about principles and framework? That is really the backdrop that will lead to your design. So you probably are familiar with it, but just to make a repetition what circularity actually is, these are circular bioeconomy principles that the food system is built on plant-based mass obtained from land and water. The byproducts are to be avoided, so leading to that zero waste. And if it's not possible, technologically, economically, or behavioral, they must be redirected back into the bioeconomy. The other part is animals play a role there as well. It's not only soil fertilization, it's also what role do animals play in that circular system, because they are very well suited to really convert and return biomass back into food much better than a human can, in a way. So how does that translate into designing that on a city level? Really start thinking about you are not solving leakages in the system, so you're not trying to find other purposes for waste, but you actually wanted to design it waterproof from the start onwards. So you actually are much more focusing on preventing byproducts by really taking a good look at what is actually happening. That good look, you do that by good mapping and quantifying of what are food and biomass resources, the flows, what's coming in, what's needed, what is used, and what is then being processed and leading to those side flows and waste materials. That really can create within a good demarcated boundary, so you can really make that head count of your resources. If you have that charted and mapped and considered, then you can have this parallel process of selecting the destination option for all these resources according to a hierarchy. And there are hierarchy, but it is you can divide it in many steps, but it is that a pyramid of prevention, using it, reusing it, recycling it, and repurposing it from a material perspective. Inclusive design, I understood you will also have a webinar on inclusive impact or inclusive design, but it's definitely also considering that you can solve something within the boundaries of your building, but you need to consider what are you shifting away, what are you transferring to other stakeholders, other places, other skills, and other timelines. So it may be solved for you, but you are actually causing problems somewhere else. Avoiding that requires inclusivity. Utilizing deep leverage point, and that is actually very well fitted with the previous presentations, which presented a lot of technological solutions, and they are great and difficult and very contributing in and by themselves, but very often it is also about, okay, so how to implement it, how to gain the commitment of the people who need to build it and use it afterwards, because it really needs to fit into their wants, needs, and behavior as well. And urban is different from national or global levels of circularity because in a way, circularity at city level from a food perspective is very difficult. There are millions and millions of people living in cities, and it is probably not possible that the food they require will be produced within the city. So there is always this interconnection with the hinterland. So how to do it? So this is something we are using. So it's just as an inspiration source, and you need to start from the bottom, basically. I kind of already mentioned it because it starts with this parameterization of supply, demands, and functions. And of who? Well, specifically the ones that are affected by your design. So it can be the users, the visitors, anyone who is actually directly involved in your design boundary. But the inventory is not only material. Of course, you need to have that inventory of side flows and residues and what is being produced and what is going into a restaurant function. Of course, that is kind of the obvious. But you also need to look into, okay, so what is actually the demands and requirements for all kinds of parts of that agri-food system. What do you need in food? What do you need in feed, animal feed? What do you need in soil and biomaterials? And next to that are the more social or societal types of demands and functions. So what role does it offer within your building? Is it to work in? Is it to live in? Is it to leisure in? Those are very different types of demands and functions. And as well, are the stakeholders capable to contribute or be part of that transformation process? Because if you design it in a circular way, it will be different from normal or conventional. It's organized different, it looks, the feel is different. Their role will be different, for example, because they need to be contributing in a community style, gardening, whatever. So it's much more socially oriented than typical linear designs. So once you have that sketched out, and I can imagine you can't do that on a highly detailed level, but it is not necessary to get that perfect. But you need to be able to consider all those options. Then you have a really big set of solutions at hand. We had a great illustrations in vertical farming. There are many more that you can be integrating into your design. So how to organize that matchmaking process is, of course, really for yourself, do the exercise of what are the options in food? What are the options for feed items? For instance, insects growing or other ways to insert animal production in your system, hydroponics, fish, aquaculture, you name it. There are quite some options there. What type of biomaterial construction and soil improvement and fertilizer as well. And you can then make choices by comparison. And you need to be setting the criteria for that comparison as well. And I'll show you a brief example in the next slide. That happens on the blue one. The decisions are making, you are making them at that challenge level, at the site level. And that is a very co-creative process. So it is something, of course, you are doing that as a student team, but if you were to do that in the real world, basically, you will have those conversations, meetings, group discussions with both the developers, the city, municipal representatives, with various groups of people who are going to work and live in that building. They will be involved in all those stages of bringing the project to life. And it's not, and they will have impact together. The design will have impact. So the considerations, what does this mean for the social context? What does this mean for the economic context and environmental impact? All those items can be considered how at challenge level it contributes to circularity performance, basically. typically, well, in our project, we want to project that to urban level decision making, because you can imagine that if within a very big city like Washington, you only have like one neighborhood or one building site that is extremely circular, what does that mean for Washington as a whole? Does it really improve the circularity of Washington itself? So city like mayors and the whole municipal organization, they are interested in what are the pilots, the initiatives that they need to support in order for them as a city to progress towards their city level ambitions for the bioeconomy. So it's the combination between, so what can one initiative contribute, how can they scale it, how can they promote other initiatives to be happening as well, so you move and progress together, basically. So having said that, some tooling, as I was explaining, I'm not going to dive into parameterization because it is fairly straightforward in trying to make an inventory of biomass flows, but the other ones are much more focused on the matchmaking. That's on the right-hand side. It's very simplified, but to make the comparison in the different both technological and other design options you have for your challenge is to have a set list, a created list by you on what indicators need to be included in your decisions. So what are actually the weighting factors that you want to consider? How important is the value of the products? How much is the conversion factor? Is maintenance a thing? Is had availability of volume, enough volume, an item? Maybe legal consequences, public opinion or awareness. Is it actually something that is favorable by consumers or the residents in the site? Is it fitting with government policy? Is it a good match between costs and benefits? Is it a technology that is really, really ready to implement, has proven itself already? Or is it okay that you are also including a little bit more innovative, newer technologies which haven't proven themselves? So you can make color coding, you can set your own range of scoring to make that justified decision, and it will look different for each team, from actually for each initiative, and that's fine as long as you are able to explain and provide the argumentation why you've chosen certain criteria scoring over others, and that makes your story, your conceptualization, also a lot better, because also for the jury it will be very difficult to distinguish if they can't follow your selection process as well. Getting back to the deep leverage points, these are the ones that are relevant in creating a really good concept that is socially inclusive. Oh, that was not me. That is really socially inclusive and actually leads to change, and not only parking a new tech in a building and see how it goes, because there's so much more required to be an actual successful site. So material things, technological bits, if you imagine, the English word eludes me, but the playground thing that skips over when weight is shifted, the weight of material and process type of technologies is relatively little if you really want to change the system. If you want to change the system towards circularity, you have to use design and intent points as well. These might be a little bit abstract and vague if you're not very familiar with the social sciences, but here it is really making use of those desires and wants and needs for the functions the site has, and really incorporate stakeholder opinion and stakeholder preferences there as well. So it is about how close it connects to those bigger goals and how you can really organize towards that changing paradigms there as well. So exemplifying, because in a way we do this process in our project, and it's actually located in Amsterdam. So we have also real challenges there as well. I'm not going to explain that in depth, but just by mentioning, and I think it also refers back to Daniel's presentation, because it does matter in your design choices if you are working with an existing neighborhood and you want to upgrade it, basically. On the left-hand side, it's a high-rise building, 115,000 people will be connected to it, either directly or in the direct neighborhood. They work together, they live together. You will have a different set of solutions there than on the right-hand side, which is actually something that doesn't exist at the moment. It's only a dream of 150 people who want to live together in as circular way as possible, but they even haven't acquired a building site yet. So they're very early on in their development process. So to accept that challenge is to really make that consideration. So what are the literal building blocks that you are incorporating in your own design, and how freeform it can be, because it does lead to very different choices there. So a number of takeaways, because I can imagine it is not always easy to step so far back that you have those answers immediately in front of you, but you can really use your imagination here. What I would like you to take away, and hopefully it contributes to your own design process, is the scaling issue. So it is, you are like targeting that one site, that one building. That's fine. You can make beautiful pictures also explaining your narrative on it. But please, please, please do not only focus on that one building. Explain how it is embedded in the wider local context, and how supply and affluence are organized if it's not feasible to do that within your system. So you really need to identify and show how you manage, organize your input and output elements, because that really makes a circular design feasible. Really focus on those design elements that address both prevention, reuse, and recycle. That can be done very much in technological style, but also in, is there an educational purpose here? Is there a demonstrator value here? So they can be really an inspiration source or a showcase for other initiatives in the city itself, or even global in other cities around the world. Another one was, I hope that was clear, to really make that balance between technological and social innovation. It would be sorry to miss out because the team has focused too much on a very small technological detail and doesn't have enough time to really consider that social area as well. What is extremely important is, of course, be aware of the needs of the end users. So who are you doing it for? What role do they play? And what type of interactions do they have with each other and with the other stakeholders in the city? So that requires to include stakeholder dialogue, imagining their needs and values. And because you don't have access to the site, maybe make that conversation happening between yourself. It's kind of a little bit of role playing, maybe even, but it is worth the effort to try to imagine stakeholder by stakeholder what they need. And for last of all, embrace uncertainty, because it is quite difficult. I'm not sure how often you already were involved in these kinds of topics, how familiar you are, but definitely it can be overwhelming, but really step by step justify the inclusion and exclusion of items. That will definitely help out a better design. That was my story. I hope you find it inspirational, and if there are questions, I will see it in the chat. Thank you very much.
Thank you very much, Hilke. It has been a journey. Very interesting presentation as well. I was wondering, because you mentioned in your presentation quite often a stakeholder involvement, and actually in your last slide you touched a little bit upon how to go about it with the role plays in your head. The point for the students who participate in this urban greenhouse challenge is that they have a little bit of access to the local stakeholders, but in principle, there is no possibility for very close interaction and collaboration. So what would be your advice on how to involve stakeholders in this situation?
Yeah, it of course it does depend if it can be happening, but it is kind of this fake it until you make it, basically. As in, I don't know exactly how big the teams are, but you have probably 5 to 10 people in the team. It is quite good to make, I don't know if you are using an online whiteboard or other way brainstorming methodology, but it is quite easy to sketch out all the different actors that you envision yourself being involved in this process. So it's both from the development stages, so that's like the architect and the builder and the ones who are financing and future user groups, but also in the implementation phase. So once the building is there, who will be working there, who will be visiting there, who will be leisuring there, maybe an education function. You can really create this brainstorm and do this role play, as in try to imagine yourself, okay, so if I was a laborer in the vertical farm, what do I need? What do I want from it? That really helps to bring out all kinds of functions that can maybe identify new ways of how to organize that. It is quite nice challenge, because those are typically things you would do with real stakeholder groups. But definitely there would be some examples available from literature or grey literature or prior challenges there as well.
Yeah, okay. And what is your favorite example of a truly circular design? Or perhaps there is no yet, and you see some...
Yeah, it's kind of, they are all the ones I'm familiar with. There's no perfection at the moment, because it is quite difficult to really have a really, really high level circularity. What I really like are the ones that are able to make the connection. I once explained our project because we're also collaborating with the zoo, and they have elephants in the zoo, and the elephants poop. And then, okay, so let's make this a circularity by design challenge with elephant poop. It's like, oh, come on, elephant poop. How does that contribute to circularity? But the design challenge is not the elephant is pooping, but what place does this feces have in that relooping system? So, okay, so what can we do with poop? Now, you can do several things with poop. You can compost it, you can convert it in all kinds of chemical components, and then see, okay, what can you make with it? Okay, that's nice. Okay, but what do the elephants eat? Okay, so the elephants eat a lot, basically. And they need to have a vegetarian diet, lots of fibers, but very diverse as well. So where do they, what are their sources of feeding them? Well, would it be feasible to feed them with some leftovers from the park, both from the cut grasses or other plants that are growing on the park, but also from the catering side? Okay, so even maybe legally it's not possible yet, but let's pretend it will be legal in a couple of years. Okay, so what part of the animals can we feed with the park itself, and what do we still need beyond that? Okay, that's great. Okay, so that's nice. So we are starting to look earlier in the chain, and then we're still with the elephant in the poop. Okay, so what can we do with the poop again? Okay, wouldn't it be nice if we grow something on the poop then we can then sell at the restaurant in the zoo? Okay, so how do we do that? Oh, maybe there is a local entrepreneur who likes to grow something. So we can grow mushrooms, we can grow insects. That would be nice. Okay, so let's find an entrepreneur that can do that. So, okay, but then you can use it in a restaurant. Oh, maybe we can also sell it to the visitors in the park. And oh, let's set up this education exhibition explaining how the elephants of the zoo contribute to the circularity of the zoo, and also are connecting with the neighborhood. Because the mushrooms, we can give or sell them to a nearby restaurant as well, which can put them on the menu. So these mushrooms come from the elephants, wow, 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 and have this unique branding opportunity. So you can sell also bags of poop, elephant poop, to your visitors, and they become part of the circularity. So in a way, it doesn't exist, it's not happening, but for me, the value here is to really consider what's coming in, what happens, and what's going out, and how can you repurpose that together with people in different functions. It is food, but it's also leisure, it's education, it's awareness, and that really helps. And that is what I really like. And this is very small scale, but on that big building with 15,000 people, you have the same idea. As well, because they need a lot of inputs. They will work around with a lot of things, and they will have affluence as well. So really try to make that story happening.
Oh, I am really disappointed that there are no mushrooms grown on elephant poo. I was really planning to visit the zoo in Amsterdam.
Yeah.
Okay, but thank you very much. I think that really explains the way of thinking and how you really put yourself in this mindset. I was just wondering, like, what, in your opinion, would be the biggest mistake then, if you want to design something in a circular way? What should you definitely not do? Or
so make it if for me, a circular design is not successful if it's only a mishmash of different options that are very standalone, and although maybe very much detailedly explained how good it is for money and nature and energy use, that's fine, because that is not that difficult to really combine things. I think the go-to is really to create this real story on a real good backdrop of why you put those things together. So it is not loose sand, but a really strong shape. And what I saw in winners in previous editions, that they were able to really create that story. They really were able to sell it, why it should look like that, and why they chose the different elements. And it is nice to consider older traditions or newer ideas or very futuristic ideas, but at least have that storyline there, because otherwise it's not convincing. And a challenge will not win if it's not convincing.
Yeah, I think it's a very good point, and it's also something that we really want everybody to take home from this webinar. So think about your story and how all the elements of your design are linking to each other. I think it's a very good point. I think it's time to wrap up our session for today. Leo and Daniel, if you could show your faces for the last minutes or so. Is there anything you would like to add to our discussion at this point? I think it creates a very nice story, actually, with different facets, and I think the people who were watching today really take a lot home for their design. So I think it will really help to come up with amazing solutions for this Urban Greenhouse Challenge. So thanks a lot for your contribution and for the inspiration. Daniel and Hilke are also coaching in the challenge, so you can reach out to them already now, but I think most of the people will use the coaching option, especially in the second round of the challenge. So remember that there are also those amazing coaches in our network. Thank you very much for this session, for presenting, for being here, for asking your questions. There was also a webinar planned for tomorrow on inclusive design. This has been postponed, and we'll inform you about the next date. So for now, have a nice evening, have a nice day, and thank you. Bye-bye.
Ciao.
Bye-bye.
Bye.
Bye.